in this equation, it looks very simple. Sine of omega equals cosine of 2 omega, right? No radicals, no fractions. It should be straightforward, but go ahead, try to factor it. You're not going to get anywhere. So we need to use some kind of a more advanced identity substitution. And the clue is very obvious in this one. Sometimes you have to think about it. In this one, not so much, because it says 2 omega. So that's a big red flag. We're going to be using a double angle identity of some kind. And I want to focus on the cosine identities, because this thing is cosine of 2 omega. So we're going to use one of those cosine ones. And the question is, which one should we use? We have 3 choices. And I'll just point out that what's in the equation right now is sine of an angle. So if I could turn cosine of 2 omega into just sines, that would be pretty nice. Okay, I'm thinking this identity right here is probably the one I want to go for. So we'll rewrite this and say sine of omega equals, and now make that substitution, 1 minus 2 sine squared omega. That's having done that, double angle identity. And now it's just a quick factoring job. You add 2 sine squared to each side to get it on the left. I have plus sine omega and minus 1. And that'll equal 0. And remember, our goal is to get this in factored form, which means I want 0 on one side of the equation. Now I should be able to factor this. So I'm going to get 2 sine omega on the left, another factor of sine omega. And now we just sort of play guess and check until we figure out what works here. Looks like a plus 1 and a minus 1. That'll give me, yep, that works. You can double check the math on that one. But basically, I'm just counting up my signs. There's a negative 1, there's a positive 2, so that works out to positive 1 overall. Then I have a negative 1 and a positive 2 sine squared. So everything works out on the factoring. And now we just solve it. We say sine of omega equals 1/2, that's the factor on the left, and negative 1, that's the factor on the right. Which means our angles, if you remember your unit circle, sine values are the y coordinates. Okay, so 1/2 is right here, it's kind of down towards the x-axis, and negative 1 is way at the bottom. So what are those angles right there? That's going to be, looks like pi over 6, and 5 pi over 6, and 3 pi over 2. Now, once you find the angles, you think you're done, just do yourself a favor, double check domain restrictions. Are there any? This should be quick. Sine and cosine, right? They have no domain restrictions. Any angle you plug in is going to be fine. It's not like we have tangents or secants up here. So we're kind of done at this point.